Okay, so first and foremost, I'd like to thank everyone that is here, all 170 of you that are here with me today. So today will be the AMAth revision session, and this is primarily for Sec 3s. So I'm going to assume that the majority of people here are from Sec 3. So before we begin, okay, make sure that you have downloaded the material. In front down there is the QR code on your screen that gives you the link for the Dropbox folder. And I believe someone has also very kindly helped me put the link into the chat as well. So you're able to download this material and use it for your own consumption. So without further ado, let's not waste any more time. I'm going to begin. So first and foremost, I'm going to introduce myself. So for those that came for my EMAth session yesterday, the slides are pretty much the same. So I'm first going to introduce myself, then we will kickstart straight into the topic. So first and foremost, okay, this is what we'll be doing today. So we'll go through a little bit of an introduction, a short little introduction first, and then we will kickstart the revision session. So I'll be covering all of those topics that I've mentioned previously. And then at the very end, there'll be a little giveaway for the curated notes as well. So it's just like yesterday, it will be one question on the screen. Fastest person to solve it and give me the answer will get a copy of the notes for free. But I'd like to say for yesterday's session, okay, for today's session, let's be a bit fair, okay, as this is primarily for Sec 3s. So if I have Sec 4s that are a little bit eager, okay, and you like to solve the question, you can do it at your own pace. But if possible, Sec 3s, please give it a try. This is primarily for you. Okay, so my Sec 4s, please try not to participate for the portion. Okay, so first and foremost, let me give a short little introduction of myself. My name is Kaiwen, and I am OVERMUGGED's O-level AMAth and EMAth tutor, and I've been teaching for about 5 years. This is my second year with OVERMUGGED, and I've been teaching for OVERMUGGED group classes and also crash courses. So currently right now, I have about 30 plus students. Majority is all Sec 4s, and they're all going to be graduating within the next 1 month and going on for their O-levels. So I've taught about 150 plus students within the last 2 years for OVERMUGGED, including crash courses and also group tuitions. So I did come across quite a lot of students during this whole period. So there's a photo of me. Okay, you can see from my webcam as well. This is my face. So currently right now, what am I tutoring? I'm doing AMAth, EMAth, and I'm also going to be taking on H1 and H2 math next year for A-levels as well. And this is my background, my education history. So I'm currently in NTU right now. I'm in my hall, my dormitory, and I'm in my 4th year of university. So what I study in uni is math. So I'm one of those weird people that like to study math a lot. And I really love the subject. I really, really love AMAth as compared to E. I will rank AMAth slightly higher than, of course, EMAth, as AMAth is a little bit more fun in my personal opinion. Okay, AMAth was my favorite subject in O's as well. And same thing for H2 math. That was my favorite subject in A-levels. So I study pure mathematics in university. So I do differential geometry, algebraic topology. I study knots, surfaces, those kind of stuff that are pretty cool. So if you look at the revision package, the cover page, there is that little diagram that I put there. That is actually something that I've learned, and I also use it as a tool to separate between my notes. So this is just a little testimonial and track record. Okay, it's pretty similar to yesterday's one. So I just want to share with everyone, these are my credentials. So first and foremost, 95% of my students for the past 5 years all have scored A's and B's for O's and N levels as well. Okay, so it's a pretty significant number of people, okay, that have done well. Of course, most of the credit goes to them. Okay, I don't take much of the credit at all. I just want to give some shout out to some of my students. I will not be sharing their names, but some of them, they really had some massive improvements. Like for example, I have one girl that came to me after the crash course in August, and then she sat for her O's in October. When she came for the crash course in August, she was scoring F9 for EMAth, AMAth actually. Then after that, all of a sudden O-levels got A2. Okay, so it's entirely doable. And I know people right now, there are a lot of people that are not doing well for AMAth. Okay, it is still possible, especially if let's say you're in Sec 4, you're worried that maybe you don't have enough time actually there's still enough time. Okay? You need to practice, you do need to work hard for the subject. AMath is not a difficult subject at all. It's pretty, I would say, it's the easiest subject among all of the different sciences, humanities, and whatsoever, because it's very brain-dead stuff. Yeah, so these are just some of the little testimonials that I've gathered from my students. Okay, so it's you can feel free to read on your own. And also, proud to say that 100% of my students all got their desired grade for the past 5 years. So when I mean desired grade, as in those grades that they are aiming for. So I have students that came to me at the start of the year failing non-stop for AMath. And they tell me that, okay, for O-levels, they predict that they want to get a C6 or C5. Okay, sure, no problem. As long as you can get your desired grade that can lead you towards the career that you want or lead you towards the path that you want, I'm more than happy to help you. Okay, and this particular student in the end got A2. Okay, so with a lot of hard work, everything is possible. So if anyone here is scared that you're scoring very badly for AMath, don't need to worry. Okay, there is enough time to actually work on it. Okay, so I want to share as well that there will be a little giveaway. So I mentioned it just now at the start as well. So this giveaway later, how it will function. Now the other subjects are doing Kahoot, but personally I do not like Kahoot at all. So I will not be doing Kahoot. I'll be just giving a question. I'll be posting a question on the screen, and whoever can give me the answer in the fastest possible time, you will get the copy of the notes. We'll send it to you. Okay. So do stay on for that at the very end. Okay, thank you for those that are updating the chat with the link. Thank you very much. So before we begin, let's talk about a little bit of the overview of the syllabus. Now for set 3s, whatever you're seeing right here, majority you have already covered, except for the calculus 3 topics down there and proofs in plane geometry. So these 4 topics down here don't have, okay, but whatever is remaining, yes, it is covered within your syllabus. Okay, and today, what I will be doing is actually the polynomials, partial fractions, binomial theorem, exponential and logarithms, trigo, coordinate geom, further coordinate geom. Now for further coordinate geom, I know some schools, they do not call it this term anymore, but further coordinate geom just means circles. So I will stop at the circle topic now, okay? Now most schools have already covered linear law, of course, and some schools do not cover binomial theorem in year 1. So if you are not, if not, it's not applicable, maybe you can just sit back for a little teaser of those topics. And I'm not covering quadratic functions, equations, inequalities, and surds, because these 3 are the simplest topics in the whole syllabus. So I'll touch more on the difficult stuff, which is especially exponential and logarithms, trigo, and coordinate geometry. And exactly what I said down here. So topics to focus on. So if currently right now you are someone that is not doing very well for AMath and you know that you can do way better, these are actually the topics that you should focus on, especially trigo. As trigo, there are so many different concepts within trigo, and it needs time. You need time to practice. Practice makes perfect for mathematics. So you need to spend some time really to go and practice. Now in Sec 4, if you realize the thing that I listed there was calculus and proofs in plane geom, which is essentially the whole entire Sec 4 year. So for those that are in Sec 4, you should already know the difficulty of the topic. Of course, if you find calculus a cakewalk like me, of course, then good for you. But I know a majority of people do not like those topics there. However, unfortunately, these topics will get harder and harder as the year progresses. So this is just a warning for the Sec 3s. If your foundation is not strong, especially in your beginning topics, these 4 topics here will GGWP. So just be careful. Okay, get your foundation right first before moving on into Sec 4. So how will this revision section be structured? First thing what I will do is that I'll be going through my revision package. I'll be going through all the different concepts, and I will also be adding on some additional stuff to the notes. So I did not put in every single thing there, as I did not want to make the notes too lengthy. So I've removed some stuff, but I will be verbally saying some things, and I'll also be annotating some things as well. So if you need, please jot them down. I'll also be sharing some exam trends, some common question types that you should look out for, questions that you should study for before you head on for your exams. And also within these sets of revision packages, there's a list of questions at the very back. Now, these questions are actually different from my monthly series. So I tried my best to make sure that I did not duplicate the questions from the monthly series as compared to my revision package. So all are brand new questions. But in the event, if I really do, then I apologize. I've gone through like thousands of questions recently, so I may have missed one or two. Solutions will be posted 1 week later. So I repeat again, solutions for all of those questions will be posted out 1 week later, and I will show you the link that would contain these solutions. So without further ado, okay, this is the QR code again for the notes, and someone already has kindly put for me in the chat, okay, the link. So without further ado, let's officially begin, as we do not have a lot of time for these topics. Someone asked a question, does your EMAF curated note contain Sec 1 and Sec 2 topics? Answer is yes. EMAF curated or AMAF curated contains everything. So whatever you need to know for your O-levels is all there. Okay. So revision package. So for the revision package, most of you that have already downloaded, now the first 3 pages is just some promotional material. Later at the very end, we'll talk about them. But for now, we're going to kickstart into page 4 of the notes. So let me explain how to use this set of notes. So of course, on top is just a little biography of myself. And then at the bottom down there is just a little database of resources. So this database of resources is basically just a compilation of everything that I've done for OVERMUGGED so far for this year. So all of the notes for AMAF are already out. So all chapter summaries are already done. The monthly questions series for February all the way to July have also been released. Solutions have also been released. Now, if you think those are only for Sec 4s, no, that's not true. Okay, these are also applicable to Sec 3s, but maybe the questions may be a little bit more difficult. So my threshold for question standards is I tend to choose things that are a little bit more challenging, as I want to challenge students. I don't want to choose those questions that are way too simple. That's why within this package are actually examples of questions from my own personal tutorials with my students. So every week for my own students, I will give them homework. And these are actually the questions, the real questions that I choose from school prelims that I want them to do, as these are pretty difficult questions. So as you try the questions on your own, okay, do wait out for the solutions. The solutions will be posted within this link. So you just need to scan this link 1 week later on the weekends, and you will be able to see the solutions for this particular revision package. So this is the contents page of everything that I'll be covering. As you can see, I did not include the topics that I'm not covering. So I did not include the first 3 topics and linear law. If you want access to those, then there is a way. Okay, there is a version out there, but I don't think anyone has access to it at the moment. If you want, you need to wait till the very end of the session, then you will find out how you are able to access those additional chapters. Okay, but for now, we're going to talk about these chapters first. So we're going to kickstart with polynomials and partial fractions. So I've combined these 2 topics together into one, and I'm also going to be sharing some important tips and tricks throughout this chapter. So I hope you guys will benefit from this additional material. Okay. So if anyone has any questions while I'm going through this topic, feel free to just type into the chat. I will reply whenever I can. But of course, if there are too many questions, then I'll keep them to the very end. Of course, if possible, all mathematics related questions first. If you want to ask me about my personal life, love life, next time, you can ask at the end of the session. Okay. And for Sec 4s, if let's say you got anything you want to ask at the very end. Okay, that is not related to these topics now. Ask at the very back. Okay, so let's kickstart officially. So this is chapter 1, polynomials and partial fractions. Oh, it's a little bit blurred. Okay, so I tried to fix yesterday's problem, but it looks like it's still happening again. Okay, but I'll try my best. Okay, so this is the topic that I'll be covering. If possible, use your own copy of the notes to actually look through. Okay. So these are the topics, and this is actually the syllabus outline that SEAB needs you to know for the subject for this particular topic. So we're going to talk about polynomials first, then we're going to hit on into partial fractions. So for polynomials, let's talk about what a polynomial is. A polynomial is basically a function of the following form. A polynomial doesn't need to be strictly quadratic, cubic. It can go even bigger. It can be quartic, quintic. It can go even sextic. It can go as big as you want, heptic even further. Okay, it can go as big as you want. But for O levels, the max you will ever see is maybe power 3, power 4. So this is an example of what a polynomial will look like. And we need to know what are the different terms of these polynomials. The reason is because sometimes questions may refer to them, especially things like coefficient, degree. So these are two terms that I will use pretty pretty frequently during my session. So you need to know that coefficient is basically the number in front of your x term. Degree is basically talking about the exponent of the leading term, which is the term with the highest possible power. So the first thing I'm going to talk about here is the remainder theorem. And this is the opening theorem that most people will see for your exams. So I'm going to define what the remainder theorem is right now using something that we call the division algorithm. So I don't know whether majority of you have covered this before. So I'm going to show you what it means. So this is called the division algorithm. F of x, okay, let me write something thicker. F of x equals to the g of x quotient of x plus r of x. So this is what we call the division algorithm. And where does this actually derive from? So where does this derive from? Actually very simple. I'm going to lead everyone back a few years right now. So imagine that when you were in P3, P4, when life was so much simpler and math was so much simpler. Okay, we're going to do a very simple division right now. So we're going to take 7 divided by 2. So we're going to put a 3 on top. So this is a 6 minus 1. And then from here, you will be taught in your primary school, like P3, P4, when you learn division for the very first time, you'll be taught to write out numbers in terms of the remainders and also the different stuff. So 7 is the same thing as 2 times 3 plus 1. And if you refer to this division thing that I wrote down in purple, it's actually the same thing. So 7 is considered as our fx or our dividend. Divisor is my gx. Quotient is my qx. And remainder is my rx. So you can write down numbers in terms of this form. Same thing for polynomials. Why is this very important? Because in your remainder theorem, this is how we're actually going to derive the value of x that we need to substitute in. So I'm going to show you a very quick example. So if I have f of x equals to x plus 2, quotient of x plus rx. A very simple way that I teach my students to remember the remainder theorem is this. Throughout this whole entire polynomial, or this function in this division algorithm, there is something that you do not have, which is your quotient. So this thing down here is something that you don't have. So the rule of thumb is this. If you don't have something, try to get rid of it. So our OBJ is to make this 0. Our objective is to make the quotient vanish, as quotient is something that we do not have. So we need to choose an x value such that when we substitute into this division algorithm, the quotient will vanish. And the way to do it is just taking your divisor, equate it to 0, solve for x. So the value is going to be f of -2 is equals to your remainder of x. And why this is the case? Because when you sub in x as -2, your quotient vanishes, and what you're left with is just your remainder. And this is the crux of the remainder theorem. It's the same thing as the factor theorem down here. So I'm going to rewrite this in terms of the division algorithm. Oops, sorry about that. Okay, we're going to label this in the division algorithm. So f of x is equals to g of x, q of x. Now notice at the back, there's a lobang. Okay, there's a hole. So what's the reason for the hole? Very simple. What is the definition for the word factor? A factor is like, for example, 2 is a factor of 4. 3 is a factor of 9. Why? Because 9 can divide by 3, 4 can divide by 2. There is no remainder. So this is the reason why your remainder is going to be 0, and there's a hole there. So it's the same thing. I'm going to give a very quick example. So the f of x is basically 2x minus 1 times the quotient. And remember that, like what I said previously, our OBJ, okay, our objective is to get rid of the quotient. So the quotient here, we want it to be 0. So objective, 0. How do we do that? We make the 2x minus 1 equals to 0 and solve for x. So f of half is 0. Okay, these are pretty simple skills for these two concepts, so I don't want to spend too much time here. Let's move on into the factors of polynomials. But I just want to mention maybe one last thing. There are some keywords that you can look out for questions that will tell you that this is a factor theorem question or this is a remainder theorem question. So example of words will be like exactly divisible, or things like leave no remainder, or things like this is a factor of this. When you see words like factor, easily divisible, and leaves no remainder, this means your factor theorem. For words like the words remainder, okay, or leaves behind, this means remainder theorem. Next, we're going to talk about this concept called the factors of polynomials. Excuse me. So we're going to solve for actually what are the different factors of a polynomial. So the one that I'm mainly talking about here is cubic. Quadratic for polynomials, of course, is already covered in the opening chapter of the syllabus. So I'm not going to touch on those, but we're going to talk about cubic functions. So how do we actually solve cubic functions? Now, I have a very special way of doing this whole cubic function thing. So it might be different from schools, but I believe most schools do the same thing. Step one of whenever I'm solving a cubic equation question, I will always type into the calculator. I will determine what the factors are going to be. And when I do so, I will be able to get out some stuff. Okay, so first thing I'm going to do, right, when I reach this kind of question, okay, I'm going to actually look for, I'm going to type into the calculator. So calculator. So please go and identify and go and figure out how do you type in cubic equations into your calculators. For those that are using the Casio calculator, you should be getting the mode 3.3 or mode 3.4. I cannot really remember. For those, I think using Sharp will be mode 5.2 or mode 5.3. I cannot really remember. So please go and check on your own devices. Yeah, I saw your question for the keywords. That one, I'll come back to it after I finish this. So for the calculator, after you get the calculator, there will be two different cases of values that you will see. So I'm going to share with everyone now. Two different cases. So case 1 and case 2. Now, what do I mean by cases? I mean scenarios. So what will you actually see from the calculator? You'll see two different things. You will see 3 beautiful answers, or you will see 1 beautiful and 2 gross. So I'm going to define everything, of course. I'm not just going to leave you like this. So what is the definition of a beautiful answer? So in my terms, beautiful answer means integers or rational numbers. So I repeat again, beautiful answers means integers or rational numbers. These are the symbols for integers and rational numbers respectively. Why do I say these are beautiful? It's because you can just read off the calculator and you can just perform your factor theorem on these particular solutions, and those will be your factors of your polynomial. Very, very simple, no effort needed. But for the disgusting answers, or what I call the gross answers, they are examples of irrational numbers. So Q with the prime, or complex numbers. So these two may be a little bit more obscure, so I'm going to define what they are for you. So when you see a Q with the prime, this means that they are irrational numbers. So the definition of an irrational number is a number that cannot be expressed as a fraction of the form P over Q, where Q cannot be 0. That's the definition of an irrational number. The definition of a rational number is a number that can be expressed as a fraction in the form P over Q, where Q cannot be 0. So for numbers like non-terminating decimals, or like pi, or like, for example, E, these are things that we call irrational, and we need to have a certain space for them and a certain method for them when we see these kind of solutions on our calculators. Now, how about the C? Now, this C thing here is not within the O-level syllabus at all, but I think it's very important to introduce it to everyone. So I'm going to introduce to you what is a complex number. Now, a complex number is basically the letter I. So if you have never seen this letter I before, you can go and try. Go into your calculator and go and type in this particular quadratic equation. X squared plus 1 equals to 0. Go and try. You will get out something. And you will see your calculator gives you a letter I and a negative I. For those that have read ahead, or for example, if you are not actually from O-levels, you are from somewhere else, and you have heard of complex numbers before, you should know that the definition of I is the root of a negative 1. So at the O-levels, we are always taught, okay, everyone is taught that we cannot square root a negative number. But when you move further, when you go into A-levels, this is going to be one of the topics, and you will then be able to square root a negative value. So what's the purpose of introducing this? There are situations when you have, like, for example, a number that is like 3 plus I in your calculator. So you can go and give it a try. You will definitely have seen numbers where there is like those very, very long things in your calculator, and then at the end there's like a letter I down there. Okay, those are what we call complex numbers, or what we call imaginary numbers. Okay. So what's the reason for me introducing this? When you see these two different types of cases, you should know what kind of processes you need to do. When we see these kind of solutions, we use the quadratic factorization method. When we see this Q, or those kind of non-terminating decimals, we use the quadratic formula. So what's the reason why we use the quadratic formula? So if you think back to every single method that you know to solve a quadratic equation, there should be 3, which is completing the square, quadratic formula, and your factorization. Out of these 3, the only 2 that will be able to give you things of irrational sense will always be your completing the square and your quadratic formula. So that's why whenever you see this kind of disgusting answers in your calculator, you will always have quadratic formula. Whenever you see this letter I in your calculator, this should tell you straight away that there are no real roots. And those are the kind of questions where you will see, please explain to me why this polynomial only has 1 real root on it. You know that one of your answers is definitely going to be complex. And the way to prove that this is a complex number, you just need to prove your discriminant. So you, at the O-levels, you cannot say that this is a complex number. They will not give it to you. You must say, because of b squared minus 4ac is less than 0, therefore, there are no real roots, and the only real solution is the beautiful answer. I hope this is clear. So for the other case number 1, there will be 3 beautiful answers. This means when you key into your calculator, you will get 3 numbers that are very nice. For those kind of cases, you should be very blessed. Those kind of situations, you can just apply this smart trial and error that I presented in this set of notes, you will get the answer. But for cases where you have 1 beautiful, but 2 very disgusting answers, then the process is a little bit more difficult. What you need to do is, first step, you need to solve out for the beautiful answer first. So you use whatever method you know to find the beautiful answer, prove that the beautiful answer is a factor. After that, you need to perform your long division to work out the quadratic side. So these 2 gross answers here will result in a quadratic formula. Okay, then after that, you proceed on to solve and whatsoever. So this is the main process on how to solve polynomials. Someone previously asked for the list of different things for factor theorem and for remainder theorem. So I'm going to go back into that. I'll write down for you. So for factor theorem, we always look out for terms like exactly divisible or no remainder. And then for the one on top, it will just be simply remainder. So these are the main few that we look out for to tell that this is a factor theorem question. Those kind of questions also where it's like, for example, they give you a polynomial with an unknown a and b. And then the question says that, oh, okay, x minus 2 is a factor, and x plus 2 when divided by the polynomial will give me a remainder of 13. Solve for the values of a and b. Standard question is definitely remainder and factor theorem simultaneous equation question. Okay. So that's why when I tell my students, right, A-math is a very brain-dead subject. What do I mean by that? The questions cannot change one. The styles are always the same. If you remember the different types of question types out there, this topic will be one of the easiest topics out there. And I believe it's some of the school's opening topic for the whole syllabus. So nothing too difficult here. Okay. Ooh. Next, we're going to talk about the cubic identities. So cubic identities, there are a few down here that we need to know. I'm going to talk about the one at the bottom. So cubic identities is a list that is not given to you during the exams. You need to memorize. So please remember the formulas for them. There is another version of them, the one that contains the 2a squared b or 3a squared b and 3b squared a, of course. So if you want to use those also can. Okay, but most of the time for questions, we will use these two. I just want to stress two very important things. Note the minus sign and the plus sign. These are different. And also, note that for this AB in the center, there is no number 2. Okay, some people like to write a square minus 2ab plus b squared, and that is wrong. So just be careful. Remember that the two purple things that I've highlighted there, okay, those are supposed to be opposites of each other. And yes, it can be derived from the binomial theorem. Next, we're going to head on into partial fractions. So I have finished the polynomial section of the topic. So I'm going to pause here for a short little while. Does anyone have any questions with regards to polynomials? No. To your question, no. Okay, I assume no. Okay, we're going to go into partial fraction. Can you move the equation? Okay, sure. Okay, apologies if the quality is a little bit bad at the moment. Okay. Will I go through how? Whoa. Suddenly so many questions. Give me a sec. Hello, will you be going through how the cubic formula can be derived from the binomial later? No, I won't. You just apply your binomial theorem on its own. It's pretty self-explanatory. How do you do long division? Wow. Okay, that one I can answer. Give me a while. What's the difference between factor theorem and remainder theorem? I've already discussed. Why is the divisor's power always lesser than the quotient? Oh, that's a very good question. Why is the Why is the remainder power less than the divisor? Okay, that's a very, very good question. So I want to actually answer that. So why is the remainder power always lesser than the divisor? Okay, the main logic is this. I'm going to use partial fractions to explain this particular concept. So when you do your long division, right, our main goal is that, okay, we all know that partial fractions, we need to split it up into proper fractions and improper fractions. And for improper fractions, we need to perform long division. So the problem that lies now is that if your remainder power is not going to be less than your divisor, when you write them out in terms of after you have completed your long division and everything, you're going to have a very big problem. Okay, you're going to be resulting left with a improper fraction again. So if you don't believe me, you can try. You're going to have that very big problem, and that's the reason why our remainder powers are always lesser than the divisor. Okay, so I'm going to carry on about partial fractions. Okay, so basically, when I teach partial fractions, I like to draw a very simple tree diagram. Okay, sorry, not the probability tree diagram, but a very simple chart to help students memorize this whole entire topic. So I'm going to find a blank space. Okay, I'm going to flip all the way to the front. So sorry about the constant shifting. So I'm going to summarize this whole entire topic right now into a little diagram. And a suggestion is this. So this is something that I tell my students all the time whenever I do revisions with them. I will always start rambling on the board, and I'll write everything from memory. So if you're able to do that, like memorize this whole entire chart or memorize the whole entire syllabus from memory, you're pretty much secured for the whole entire subject. So of course, right now when I'm teaching, I need to refer to my things because I need to remember every single thing to say, but my main template is always in my head. So a suggestion is that if you can always regurgitate everything out again, same thing for your other subjects. It will help you in life. It will help you master all your other subjects as well. So I'm going to draw this chart, and this chart is a very simple chart to understand. We're going to start off in the center with partial fractions. So partial fractions. And all partial fraction questions or all partial fractions are always written in the same form. Px, so I'm going to use another color, Px over Qx. If my handwriting is a little bit bad, I do apologize. So today is not my day for handwriting. I'm sorry about that. So partial fractions are always written in the form of a polynomial over a polynomial. Now, some people may ask this question, why? Then what happens when there's a number on top? Oh, a number is also considered as a polynomial. It's just that your x is powered 0. So for partial fractions, now, there's one question that we always need to ask ourselves, whether the fraction, is it improper or proper? So I would like to branch from here into two separate directions, and I'll talk about proper and improper. So let's talk about the proper fractions first and what defines a proper fraction. So the definition of a proper fraction is when the degree, so remember what's the definition of degree? Degree's definition is the highest power of the leading term, basically. Okay, what is the power of the leading term? So the degree, this is the condition. So maybe I'll write in another color. The degree of your numerator, which is Px, must always be smaller than the degree of your quotient of x. So I repeat again, the condition for a partial fraction or for a fraction to be proper, it must be degree of the numerator be smaller than the degree of the denominator. I'm going to give you a very simple example. X over x squared plus 2. Notice that the top degree is 1, denominator degree is 2. So this is a proper fraction. I'm going to move into improper now. What is the condition? Is slightly different. So the degree of your Px is greater than equals to, the one I want to stress is the equal at the bottom. So there's an equal sign here to the degree of your Qx. So a very common mistake that many students make for this particular topic, okay, is that whenever your powers of your numerator and the denominators are the same, this is considered as an improper fraction. Okay, I'm going to repeat one more time. When the powers are the same, this is an improper fraction. So examples, okay, the classic ones, very, very simple. 2x squared plus 3 over x. This is obviously going to be improper. X plus 2 over x plus 3. This is improper. So please be very careful. This is one of the very important cases that a lot of people will forget. Please do not make mistake. When you say degree, does it mean the power of x? Yes. So I'm talking about the biggest possible power in the polynomial. So if you check on the very first page of the polynomial set of notes, the definition of the word degree is actually written there. So that's what I mean by degree. So these are the two definitions. Oh, I'm running out of space. Wow, that's fast. Okay. So now if we are dealing with when we are dealing with the improper side, remember, if this is an improper fraction, after that, what we need to do is to perform long division. So here, we go for long division. So when we do long division, okay, after we proceed to long division, we need to remember that the resulting polynomial must be proper. So just take note, please do not do your long division and then you realize like, how come the resulting fraction still have the exact same problem and it's no longer going to be still improper. So condition here is that the degree of your remainder must always be smaller than the remainder of your divisor. So let's define out remainder divisor. So I saw someone ask me the question, why is it that x plus 2 over x plus 3, why is this going to be considered as improper? And you quote me an example like you plug in number 1. Okay, very simple. You can sub in other values. Because now the problem is that, right, when you are substituting just one single number to prove me wrong, that's not good enough. So I can quote you so many other numbers in the whole entire universe that will prove that this is considered as an improper fraction. So your proof is no longer valid. Okay. How about x squared plus 4 over x squared plus 9? An example in the exam. What's that example? X squared plus 4 over x squared plus 9. Still considered as improper, of course, because power on top is equals to the power at the bottom. To make it proper, we only look at the powers numerator higher. Yeah, correct. Wait, what? No, that's wrong. For proper fractions, we do not need long division. It's only improper, then we need to do long division. LD stands for long division, long division. But any number you substitute. Okay, wait. So let me say again. Let me define one more. Let me say one more thing. Okay, do not sub in values to tell me that this is an improper fraction. That's wrong. Okay, the main concept that you need to understand for an improper fraction, stop thinking about it as numbers. Okay, you cannot use numbers as an example in this case. For improper fractions, the condition is that as long as your numerator's highest power is bigger or equals to your denominator, it will be considered as an improper. Okay. So if the power on top and below are the same, do we still need to do long division? Answer is yes, we do. Okay. So someone asked, how do you divide x plus 2 over x plus 3? Sure. Okay, I'll do it very quickly. It's just this. So we put the x plus 2 inside. We put the x plus 3 inside. And we ask ourselves, what times x will give me x? 1 more. So minus x plus 3, negative 1. So therefore, this will be 1 minus 1 over x plus 3. X squared plus x squared plus x power, no, to the one they just said that x squared plus x squared over x power 1 plus x power 3. No, that is proper because your numerator is 2x squared. Your denominator is x cubed plus x. So it's x squared over x cubed. So it's proper. So after we complete this improper thing, okay, and then now we can reconvene in the center. And we have 3 different cases. Okay, so the 3 different cases are going to be linear, repeated, non-factorizable. So for this particular tree, okay, later I'll just go straight into the notes to explain. So this is basically the tree that I like to draw for students to help them memorize this whole entire topic. Okay. So let's go back into partial fractions. So these are the three formulas that you need to know. The one that I want to stress is about the repeated linear. Just be careful that you need to repeat the one of the fractions again. Excuse me. For your x squared terms, okay, please remember to go and repeat. There's one example that I want to stress that is a very common mistake that a lot of students will make. So let's, for example, x over x squared times x plus 3. This particular case, okay, is supposed to be this x squared here. Okay, this is considered as a repeated. So you must have a b over x plus a c over x squared. This is a very common mistake. Just be careful. Where is bx minus c? Sorry. Yeah, for those that say that there's an error, where is it? I don't see it. Like where? I don't see the bx, the negative bx minus c. This one. Like here. It's positive what? Yeah, I think when I circled, then I covered the minus sign. Oh, okay. Yeah, someone wanted the diagram, right? Okay, here you go. So this is the diagram that I'm interested in. Okay, so please remember this diagram is pretty important. Okay, so yeah, what if both the numerator and the denominator have the same power? There is also the possibility that okay, wait, let me just say, okay, no, okay, if numerator denominator is the same power, okay, it is an improper fraction. Okay, I do not want to argue. You don't believe me, you can go to your school and ask your teacher. Okay, if your teacher tells you that it is a proper fraction, your teacher is wrong. Okay, I guarantee you. Okay, that is confirmed wrong. Okay, it is 100% considered as an improper fraction. Okay, I don't want to repeat this thing again. Okay, so yeah. No, I will not be uploading the annotated version of these notes. The answer is no. Okay. So we're done with partial fractions. Is it quotient plus remainder over divisor? Yes, correct. Whoever asked that. Okay, we're done. So this is the end for partial fractions. Does anyone have any question? Can you explain why x squared is repeated? Oh, because I mean there's nothing to explain, because x squared is firstly start with x and then x squared. Okay, okay. Now let's move on. Okay, we're going to move on into binomial theorem. So this is the next topic that I'll be touching. Okay, so binomial theorem is the next concept here. So let's talk about binomial theorem now. Now this topic is not difficult, but there is a certain variant of questions that is pretty tough. So I'll talk about them in a while. Okay, so we discussed the main portions of the chapter first. For those that are not covering binomial theorem in their first year, okay, then just take this as a little teaser for what is upcoming. So for binomial theorem, first thing about a binomial expansion that we need to remember is that the power, okay, must always be integers. Now for the O-levels, your powers are always integers and positive numbers. So this is very important. Okay, you cannot binomial with a negative power, and you cannot binomial with the positive power as well. Okay, so just be careful. So that is that. And then also there are formulas that you need to remember. Okay, for binomial theorem. Now, you don't need to actually memorize the formulas. You just need to refer to them in your formula sheet. So a suggestion is actually to memorize. For me personally, I just memorize. It's nothing too difficult. Okay, the main one given is the first one down there. Okay. Next, we're going to talk about the important terminologies and conditions for binomial theorem questions. The one that I want to stress will be the conditions, as also conditions is something that, these conditions are things that a lot of students will forget. So just be a bit careful. let's stress the conditions part. So first thing is that whenever you're calculating the value of r, your r must always be a positive integer. So whenever you are working out your, for example, TR plus 1 form or your general form or whatsoever, and you solve for the value of r, this r here must be a positive integer. So if a question asks you to show the existence of a certain term, we always use this r thing, okay, to actually prove that whether this is considered as a valid term or not. The second condition is the number of terms within the binomial itself. So for the whole entire binomial theorem, it's just like, for example, when you expand a plus b whole thing squared, there will always be 3 terms. A plus b cubed will be 4 terms, that kind of thing. Okay, it will always be n plus 1 terms. Okay, so just be careful. Then also, whenever you are seeing questions that deal with reciprocals, okay, you must remember that we always pull the variable up into the numerator by changing the powers using indices law. Now, the one that I want to stress is this. This one, just be a bit careful. We do not pull the 4. The 4 remains in the denominator. Okay, it just becomes a 3/4. Very simple example. The x only moves up, and the only time when it moves up, you must take a negative power. Okay. Someone asked, how do you get back on track when you realize your r is negative when doing a question? Okay, interesting question. How I just restart the question, no? So just restart and check your working. Most likely you messed up when you're working somewhere. Reciprocals means taking 1 over something, okay, or fraction. Next is the next page. Okay, this one I want to stress a little bit. So this one, when you say unknown powers, this one need to be a bit careful. Whenever you see questions with like unknown powers in your question, these questions are going to be a little bit more difficult. So for example, questions will give you like, oh, okay, expand 1 plus x to the power of n. And then after that, the next parts will be asking you to do your selective expansion or your rainbow expansion or whatsoever. Okay, you need to know how to use your binomial formula. So n choose 1, n choose 2, n choose 3. These are the main 3 that always comes out. So a suggestion is to actually memorize these formulas. Of course, if you know how to use the formula that is given to you in the formula sheet, then of course you don't need to waste brain space to memorize. Okay, but if the unfortunate incident that you do not know how to use it, then please memorize the following formulas here. For especially n choose 1, n choose 2, and n choose 3, as these are the most common ones that will come out. I'm going to show you an example of a question that deals with a power n on the next page of the questions there. So that one, we will talk about that. One last thing I want to say before we go to that is we go back one previous page. I forgot to say something. General r plus 1 term, which is here. So the general r plus 1 term, this general r plus 1 term is always used to identify things that are like smack in the middle. So very simple example questions would be like, find for me the coefficient of x to the power of 4. For example, in your binomial, you have no clue where this x to the power of 4 is going to be. Maybe if it's very nice, maybe x power 4 is the 4th term or 5th term. Maybe, we do not know. But what happens if your binomial power is power 50? Where are you going to find your x power 4? There's no way to identify. The only way you can find is by using the general r plus 1 form. However, okay, if you feel that this general r plus 1 form is very difficult to remember, actually it's given to you. It's just not obvious. It's here. If you check your formula sheet, at the very end of your binomial formula, there is that n choose r, a power n minus r, b power r. That is actually your general r plus 1 form. Here. So you can actually use that for your expansion. Okay. Very good. So that is basically it. Okay, now I will take questions for binomial theorem. Okay, wait, a lot of people are sending me direct messages. If possible, can put it to chat for everyone to see, so that it'll be a lot better, so that it doesn't seem like I'm talking to ghosts. Okay, someone asked me, how do I expand 3 terms? Okay, that's a very good question. So if you're dealing with 3 terms, now at the O levels, most of the time for 3 terms, you will be given a substitution to do the question. So I'll give you a simple example. 2015 O-level paper, there was one question, 1 + x squared power 4, for example. How do you expand this? We group. So we group these two together and we just apply the binomial as it is. So this is A, this is B. It doesn't really matter how you group. You can group it as 1 + x squared, also can. You will get it. Next question. If the power is n, how many sets of brackets are we supposed to give? Okay, very good question as well. So for power of n questions, for me, rule of thumb is to always expand to where you need to expand to. So you do not expand blindly until infinity, of course. So for example, if the question is asking you for x squares, what you should do is to go and ask yourself, okay, how far do you need to go? Look at whatever you're multiplied with and ask yourself, okay, what is the limit of where you need to stop at? And that will tell you how far to go. Can you solve an equation using the binomial theorem? Not now, because that will take a while. Okay, so later. How to do comparison in binomial? Okay. Sorry, I don't really understand what do you mean by comparison. Can you give some examples? Oh, okay. So I'm going to give you an example of a question that shows you unknown power expansion. So if you look at this whole entire page here, basically every question here is on unknown power expansion. So if you look at the very first one, in the expansion of x cubed plus minus 4 over x to the power of n, in descending powers of x, the 13th term is independent of x. Find the value of n. You can see that the n here, okay, this is an example of a power n question. Maybe for this one, you don't really need to use the formulas, but for this one, definitely need. Okay, you need to remember. Okay, take questions for another 1 minute, then I need to move on because I got a lot of things to do today. How do you know where to expand to when they ask for the 1 over x squared term? Okay, very good question. I'll just do a very quick one, if I can find it. Okay, for example, this. Okay, let's look at this example here. So hence, find the coefficient of x cubed in the following expansion. So we are looking for x cubed term. So a very simple way that I like to do this kind of questions is to ask myself questions first. You look at this thing that you're multiplied with. So this is the binomial section of the question. This is the bracket. We're going to ask ourselves, 2 times what will give you the x cubed term? X cubed log. Px times what will give you x cubed? X squared log. 5 over 2x squared times what will give you x cubed? X log. So you know the max you need to expand to x cubed. That's all. Can you explain the general r plus 1 again, and how do we use it with example? Okay, that one a bit long. Wait, let me see. How do you explain the general r plus 1 again? How can you use it with an example? Okay, so I don't have a question right here, so it's a bit hard to explain. Okay, for example, this. So, for example, for part B, part A, part 1, the question is asking you to figure out what is the general term. We just apply the formula. So, n choose r, 6 choose r, x squared to the power of 6 minus r, 1 over x to the power of r. It's just applying a formula. Okay, so someone asked about grouping, something like this. How do you group? So you group like this, and then you just carry on like how you're supposed to expand, and then you will get it already. Okay, so for example, you will just do, for example, I'll just do one term, 8 choose r, 1 to the power of 8 minus r, negative 2z plus z squared to the power of r. Now, of course, you're supposed to use the part above, but I'm just showing an example. Okay, then you just repeat the process. Just imagine that the bracket is like your B, and then you get it. Okay, sorry, I do need to move on. So later, for those that still have questions on binomial, you keep your question, and then I'll come back to it at the very end. Okay, so apologies, because I have a schedule to run. Next, exponential and logarithms. So I do have, still got quite a lot of topics, oh my god. Okay, so exponential and logarithms. So this is a topic that I know that is a pretty big pain for a lot of people. But to be very honest, I don't agree lah. Okay, I think this is a very simple topic. Okay, the only thing about this topic that is difficult will be the equation section. So that one I will talk a little bit more. The general stuff, I think nothing much to say. Excuse me. So exponential functions are always in the form of a to the power of x. So there's a e, or for example, base 10. Okay, these are examples of exponential functions and their graphs. They are being shown here. Now, these 4 graphs are things that you need to memorize. So within the 4049 O-level syllabus, there are a few graphs that you need to know how to draw. Quadratic functions, trigo, exponential, logarithm. These are the only 3. Okay, nothing else. So please go and memorize, go and check what is the value, what are the key values, what are the values that you need, okay, that will give you the following graph that you're going to get, okay. Next will be your logarithms. So logarithm functions are those with the log or ln. Okay, same thing, the graphs are also shown here. Nothing much to say other than just it's pure memory work. Okay, so nothing much to remember. Personally, one thing that I've learned from a student, okay, if you look at the palm of your hands, okay, look at the palm, okay, my hand a bit fat, but you look at the palm of your hand, right? If your hands do not have the lines, then too bad. Okay, but let me just check if my video is showing well. Hello. Okay, very good. So you can see the palm of my hand. I know it's a little bit fat at the moment, but you can see that there are lines going up and there's a line going down this way, right? Yeah, this is your exponential curve. This is your logarithm curve. This is how I memorize. So one side is negative, one side is positive. So negative graphs, go here and go down. Positive graphs here, go up, go down. Done. Okay, so pretty cute way to memorize logarithm graphs using the palms of your hand. But if let's say your hands do not have the line, then unfortunately you need to do it on your own. Okay. Next will be the laws of logarithms. So these are the important laws that we need to remember. Okay, so the ones that I want to focus on will be the addition law and the subtraction law. So just be a bit careful. For the addition law and for the subtraction law, please do not confuse yourself with the common mistake. There's a section down there at the bottom of the page that talks about the common mistakes. Please do not make mistakes. Okay, the addition of 2 logarithm terms is just going to be negative. Okay, so for what am I saying? Sorry, the addition of logarithm terms is going to be a multiplication. The subtraction of logarithm terms is going to be a division. So just be careful. Okay, next one is the power law. Now, for the power law, you need to be very careful about one example. So this one here is not inside, so I suggest to write down. This is something that came out for a recent school prelim that was pretty tricky. So ln x holding squared. Is it correct to do 2 ln x? No, okay, this is wrong. Okay, it is wrong to pull the 2 down like that because the square, okay, is actually for the squares up there is actually for the whole entire thing. Okay, it's not just the x. If you want to power bring down like this, you need to make sure that it's only for the certain term. Same logic as this. If you have y equals to the ln of ax squared, okay, it is wrong to say y equals to 2 ln ax. Okay, this is wrong as well. Okay, this is wrong. You're not allowed to do that. So just be careful. Next, we're going to talk about same base. So if the base and the index are the same thing, then it should be 1. Okay, next will be change of base. So change of base formula, just remember that we always take the index over the base. Okay, and these are the formulas. Now this one is a pretty good formula to use as well. Okay, if you take the reciprocal of any logarithms, you're just going to flip the terms. Okay, the index and the base. The very last one at the bottom here is the changing of form. So what happens when you change the form of a logarithm term? Okay, you just need to keep the b here, and then you just your base a to the power c, and then you will get it. Okay. For the changing of logarithm form, this is a pretty common thing that we always use during the solving of logarithm questions. So just remember that this is an important step that we need to take. Okay. Last one is about the common mistake down here, which is the cancellation of logarithm terms. So you need to be very careful whenever you want to remove, quote unquote, remove your logarithm terms. You need to make sure that on the left and on the right, okay, on the left and the right, there's only one logarithm term, not two. So if you have things like log AU plus log AV equals to log AW, you want to remove the log A, can, no problem. You need to group up the two on the left first into one term using the addition law, and then you can split it up. Okay. Another common question that I always get, if you see this come out, how do you actually solve? Okay. So how do you actually solve this kind? You need to perform other stuff. So for example, if this is, for example, we talk about the right-hand side, is equals to like 2. We just need to say u minus v is equals to a to the power 2. That's all. And then we can move on with our life. Okay. Yeah, for someone that's asking how to solve this, right? Okay, this was a differentiation question. So actually it's nothing. It's just wanted to share this concept. So there's actually no way to continue solving for here. Okay, it's just another question embedded somewhere. Yeah, I just remembered it. Someone asked a very good question. Why is it that logarithms bases cannot be negative? Okay, simple reason. So why is it that logarithm bases cannot be negative? So for example, if you see that log -1, 3, okay, I'm going to change base. So I'm going to change to ln3 over ln1, -1. Is this possible? No. You cannot learn a negative number. This is the simple reason why. Sorry, can you repeat how? Oh, okay. How do you memorize the palm? Okay, basically you just need to look at your palm lah. Okay, so I'm gonna show my palm one more time. If my video is flipped, I'm sorry about that. Okay, I'm looking at it. I'm looking at my hands now. So if you want, you can look at your hands as well. Okay, okay, maybe I draw the hands. I think that would be easier. 1, 2, 3, 4, 5. Okay, sorry for drawing the middle finger so big. 1, 2, 3, 4. Damn it. Okay, never mind. So like that. Okay, and then the palm is like one like that, one like that, and then one like that, one like that. Okay. So this is your positive side. This is your negative side. Okay, everyone happy? This is the right hand side. This is the left hand side. What happens when the bases have a squares or cubes? Same thing, change base. So you just change back into the basic base law. So for example, if it's like log √2, 3, log LG3 over half LG2. That's all. Okay, that's all. So nothing else to say. For logarithm equations, if let's say you're not good at solving logarithm equations, then you need to practice lah. Most of the questions are actually the same type. Most of the time, the few things that we commonly need to do will be to change base. Okay, and then after we change base, we group everything together, cancel the logarithms, or change form. Then we solve the question. Most of the time, logarithm questions are done this way. So please practice. Okay. That's all. So there are some questions here on logarithm questions. Now, there are some things here that are pretty common questions. Like for example, question 3. This is an example of an application kind of question. This is very common in exams as well. Okay, you need to know how to solve them. I'm not going to solve the whole question because I don't have the time. Okay, it should be sufficient enough. Next, coordinate job. So 2 more chapters, and then I'm officially done. I aim to finish. Excuse me, sorry. I aim to finish by 8:35, 8:40. I try my best. Okay. Okay. Someone asked a very good question. Why does when t approach small, t becomes very t? Okay. Yeah, someone asked that question. Okay, it's a very good question. So someone asked the question, why is it when for exponential functions, when t approaches infinity, exponential functions approach to 0? Okay, what's the reason why? It's very simple. Draw a graph. Okay, because at the O levels, you're not taught the concepts of limits. So it's a bit difficult to understand why this is the case. Okay, but if you don't believe me, you just need to draw. You can go into Desmos or you go to GeoGebra to go and draw the logarithm curve or the exponential graph. So for example, if this is t and this is y, okay, we have to sketch your logarithm curve, your exponential curve, sorry. Okay, it'll be like that. As your t grows very big, okay, you just need to keep on going and going and going and going towards the right of your curve. You will realize that you will approach 0, but you will never ever touch 0. So for the O levels right now, you just assume. For right now, as the numbers go as big as possible, the numbers are going to go towards 0. Not exactly 0, but 0. Okay. Good question though. Thank you for the question. So I'm going to move next to coordinate jump. This one, it'll be pretty fast because there is nothing much here. The prerequisite for the EMAF side, I will not be doing. I will just be doing the AMAF things. So number one, we talk about the midpoint. So for the midpoint of a line, we need to remember that this is the formula that we use. X1 over X2 over 2, Y1 plus Y2 over 2. And this will give you the midpoint of the line. You can think of this like finding the average between 2 points. It's the same concept. Okay, this is nothing difficult. What's the reason why we need to do midpoints is because of perpendicular bisectors, and we need to find the equations of perpendicular bisectors. So, for example, you need to know the process of finding the equation of a perpendicular bisector. So let's recap the process of what the perpendicular bisectors are going to be like. So what's the definition of a perpendicular bisector? So for a perpendicular bisector, an example of, the definition of a perpendicular bisector is a line that cuts the bisector that cuts the line exactly in half. I repeat one more time. Okay, is the, for example, if you have a line AB, okay, is the bisector that cuts this line AB in half. So with the very fact that we are cutting it in half, we know that we need to find the midpoint. So for AMAF, we know this formula, which is the alternative equation for a straight line, which is y minus y1 equals to mx minus x1. Now, some schools do not actually teach this formula. If they don't, then it's okay, no problem. But personally, I like this formula a lot because it's a lot more useful than y equals to mx plus c. So for this formula, you just need to figure out what is the midpoint and what is the gradient of the perpendicular bisector. For the gradient of the perpendicular bisector, you just need to remember that when two lines are perpendicular, it is equals to -1. The product of the two lines gradients will be -1. So therefore, the gradient of a perpendicular bisector will be -1 over the gradient of the line. The last one down here is the area of a rectilinear figure, or what we call the shoelace method. So for the shoelace method, this is what the main formula looks like. There are some things to remember about the shoelace, which I want to stress. Number one, the modulus signs. So I understand that modulus has been taken out from the O-level syllabus. It's no longer inside there. Okay, but just remember that the purpose of these two lines down here is to just force whatever number that is within this particular bars, okay, to force the numbers to turn positive. Okay. So just this is one of the most important things. Now, number two, okay, is to look at this x1 and y1. You must remember that whenever you are doing shoelace, you have to repeat the first number. Okay, you have to repeat the coordinates of the very first point that you choose. So yeah, just take note of that. And the very last thing, okay, I know I underlined the word anti-clockwise here, okay, but I'm just going to share a fact. It is actually not important which direction you choose. The only thing that is important is everything must follow in chronological order. So for example, if your figure is like that, right? And you do A, B, C, D, you have to do A, B, C, D, or you do A, D, C, B. Can. Okay, you cannot do A, C, B, D. That one confirm cannot. You will get it wrong. So just be careful. You can choose whatever orientation you want, but most schools just teach you anti-clock to make life a lot easier. But if let's say you forget and you accidentally did clockwise, the only difference is that within your bars of your modulus will be negative, and then the modulus will turn your numbers positive. That's all. Yeah, so the thing is that whatever that I just mentioned here, these are strictly for AMath. You're not allowed to use these formulas for EMath, but you can use your EMath stuff for your A, okay? Because AMath is just an addition towards your E, okay? Can do B, C, D, yeah, sure. You can do in whatever orientation you want. It doesn't really matter. Okay, so if you go clockwise or you go anti-clock, okay, whatever works, okay, make sure that your calculation is correct when you're calculating your determinant here. Okay, if you get it right, then you just, if let's say your answer turns negative, then you just force it to turn positive. The answer will be correct. Okay. What's that? If EMath gives us all the coordinates of a triangle, can we just use shoelace? No. Okay, for the rule of thumb is this. EMath, please do not use shoelace. Okay, it's not worth the effort and it's not worth making mistakes, especially if you're not strong with the shoelace. So suggestion is that if the question, EMath is designed in the way for people that do not take AMath. So you must think of those people that don't take AMath. They must be able to solve the question without the shoelace method. So do not use the shoelace. I saw someone say that you can, but if it's wrong, there's no matter mark. Okay, that's true, it's a fact. But the rule of thumb is just don't use. Okay, just make it simple, do not use. Okay, and it'll make life a lot easier. Next, we're going to go into circles. So when we go into circles, so this particular topic on circles is not the easiest topic in the whole entire syllabus, okay, but no choice. Oh yeah, I saw your question. Examples of shapes that have midpoints. Parallelogram, rhombus, okay. Example of shapes, okay. Equations of circle. So let's talk about that first. So I have equations down here, the standard form and also the general form. It is important to know the difference between the two, and we also need to know the name. So we need to know that the top one with the squares is called the standard form, and the one with the G's and the F's are considered our general form. The formulas are also given there for the center and the radius. Just be very careful. Do not confuse yourself with this R square and the C, as this is a very, very common mistake that a lot of people make. So sometimes exams love to test questions where they give you the general form and then they purposely put the C as like a perfect square number. And then, a lot of people will just see the number and just go and square it, and that will assume be a radius. That's not true. Be very careful. Next, we're going to talk about 4 of the most important concepts that regard circle questions. There are 4 down here that you need to know for the O-levels or for your exams. The first one will be inside, on, and outside. So this concept is basically, the questions will ask you to determine if a point lies inside, on, or outside the circle. The very simple way to test is to test the length between the point towards the center. Okay, so just refer to the table here. If the radius of your line is actually bigger than the length, when I say length, I mean between the point to the center, then obviously the point will be inside the circle. If it's equal to the radius, it will be on the circle. And if it's less, or if the length is actually bigger than the radius of the circle, it will be outside. Okay, so just take note of that. Next, we're going to talk about normals and perpendicular bisectors. Now, the word normals is actually a Sec 4 term, so we can ignore that for now. We just talk about perpendicular bisectors. So whenever we have tangents and perpendicular bisectors on a circle, just remember that all perpendicular bisectors will intersect at the center of the circle. If you refer to my yesterday's EMath session, I did explain why. This is the reason of a circumcircle. Okay, that is the circumcenter. Next, we're going to talk about the reflections. So reflections is a very important concept as well. So I have a very interesting way of remembering the reflections. So I'm just going to give my most common example that I always give. Okay, if you have heard me say this before, then good for you. Okay, if this is the first time, then yeah. Okay, reflections is just imagine like you're looking at a mirror. So I'm going to only talk about the y-axis as it's the easiest one to explain. So I'm going to use myself as an example, so I believe everyone can see me, right? Okay, so my y-axis, imagine that I have a mirror in front of me. I'm going to explain all of the different concepts down here very, very quickly using this mirror example. So number 1, let's say, for example, if I am looking at a mirror and I'm standing 2 meters away from the mirror. Now, we all know that within the mirror, you should also see yourself, right? Inside, right? So when you see yourself inside the mirror, where will you be positioned? Will you be positioned 2 meters from the mirror, very, very, very far away from the mirror in the image side, or will your face be like that to the mirror? If you see when you look in the mirror, you see your face like that, it's very scary, it's 7-1, okay, that's very scary, so no, it's supposed to be the same. The distance between you to the mirror should be the same distance between the mirror to the image. And this is the reason why this length here is equal to this length. So that will explain the A's. The distance between the center of the original circle to the y-axis or your mirror will always remain the same. So that's number one. Second concept is this. If you look at a mirror, okay, so imagine a mirror in front of me right now, and you can see me, right? I hope everyone can tell that I'm a little bit fat. Okay, I'm a bit big size. So if I look at a mirror right now, okay, when I see my image looking at the mirror, will I see the exact same body size that I have right now? Or will I be skinnier? Or will I be even fatter? Okay, I wish I can be skinnier, but unfortunately cannot. Okay, so I will obviously see the same size. So this is telling you that the radius of your circle do not change. So when you look at the image, okay, your circle size should exactly be the same. Last concept is which coordinates would change. So the only thing that is changing right now is your center coordinate. So you just need to change the center coordinate. And how do you tell whether to change the x or the y? Very simple. So imagine if I'm looking at the mirror right in front of me again, okay, and I'm looking straight into the mirror. Where will I be? Will I be exactly where I am in terms of the mirror? Okay, so in the mirror side, exactly where I'm at there? Or will I be to the left, to the right, on top, or floating down? Okay, like half my body is gone. Cannot be, it should be exactly at the same location. So the moral of the story is this. If you're reflecting about a vertical mirror like this, the x coordinate will change, the y coordinate do not change. Okay, it's not possible for your body to be floating up. It's not possible for your body to be floating down. So it must be exactly the same. Therefore, the y coordinate do not change. Okay, the only thing that changes is the x coordinate. So these are the examples of the mirror that I like to give. These 3 examples, I hope it helps you remember the concepts of reflections. The last one is also talking about the equations of the tangents to the circle. So sometimes questions will ask you to figure out what is the equation of a tangent. Now at the O levels, unfortunately, you do not learn implicit differentiation. So there is actually no way you can differentiate your curve, assuming that you guys are Sec 4s. Okay, so the only way that you can do it at the moment is to first thing find what is the gradient of the line starting from the center to the point. That will be aka your radius. After that, remember that the product of the gradients of perpendicular lines is -1, and then you figure out the gradient of your tangent line. After that, use your y minus y1 equals to mx minus x1 formula, okay, with the point P that they tell you to solve the question. And this is how you do the whole entire question for tangent. Okay, 3 steps that you need to remember. Okay, hope you remember them. So for circles, just take note as well. Okay, it's not a very easy chapter at the very start because there's a lot of visualization and the topic can get a little bit complex, especially if the questions are a little bit tough. So just practice as much as you can. Try to look for questions that deal with all of this as much as possible. Okay, repeat the steps. I wrote down the steps. The steps are all here. Yeah, I'm just repeating off whatever I've written here. It's the same thing. Okay. Sorry, I don't have the time to give an example. You can look for all those solutions that I've uploaded before. They're all there. Okay, apologies for that. Okay, if anyone has any questions with regards to circles, okay, I'll answer them later. Okay, so hold on for a while first. Let me finish Trigo. I do my other stuff that I need to complete, and then I'll host a little Q&A at the very back. So, next thing I want to do is Trigo. So this is the AKA deaf topic for most people, but I feel that this topic quite fun now. Okay, so this topic here will be split into 4 different sections. Now I know some schools are not teaching all, they don't test you all the concepts, but this topic is going to be one of the major hits for O levels, because of the nature of the topic and this how big this whole entire topic is going to be. So I summarized this whole entire section into a few pages, and I hope it will be sufficient enough to guide you through towards your exams. So the opening thing that we need to remember is the trigo ratios. So tokaso, tokaso's sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. The way that we memorize is using tokaso. Remember that tokaso only works for right-angled triangles. So just remember that, okay, you cannot use them for any of your convex triangles or any of your other types of triangles. Not possible, you need to use other methods. Next is principal values. Now, principal values, this one, just be a little bit careful. I believe for the, how many people are here? 189. For the 189 people that are here, okay, I believe some schools actually do not teach this concept at all, okay, which is very scary, as this is actually in the syllabus. So just remember that for sine inverse, cosine inverse, and tangent inverse, these are the principal values that you need to remember. The reasons why these principal values work, you do not need to know now, as it's a little bit complex to explain. So just take this as a memory work, memorize especially these last three. Okay, if you cannot tell the difference between a square bracket and a circular bracket, you don't need to know it. Okay, just ignore that. Okay, just look at the one that I just highlighted in gray. These three is things to memorize. The one that I want to just draw your attention to will be the inequality symbol for sine and tangent. For sine, the inequality symbol should be less than equals to. For tangent, it should be less than. Very simple reason why. Because at pi over 2 or negative pi over 2, tangent is asymptote there. Okay, it's asymptotical at 90 degrees and negative 90 degrees. So there are no values there. Hence, the symbol should be less than and not less than equals to. Next, we're going to go into the reciprocal ratios. So these are the three new ratios that are being introduced into the A-Math syllabus that is not in E-Math, okay, which is your secant, cosecant, and cotangent. So I just want to say something first. Now, within this whole set of notes, if you were to receive this batch, if let's say within the questions or any of my answers, you see CSC instead of COSEC, just take note that it is actually just cosecant. The very simple reason is because COSEC is technically not a real thing. It's meant to be CSC, but I don't know why schools just teach it as COSEC. So if it's COSEC, then fine. Okay, but sometimes I might just revert back into CSC accidentally. We just take note that that means COSEC. Now, a very simple way to memorize the trigo functions, okay, is you look at the third letter of every ratio. So for example, for cosecant, the S means sine, secant, the C means cosine, and T, cotangent, means tangent. So just remember this, nothing too difficult here. Most people should be pretty accustomed to them. Next is special angles. So this is a list of special angles that we need to know and memorize. Now, of course, if your head don't have enough brain space, you don't actually need to memorize this. You can key them into your calculator and you can get the exact answers out. If you're interested in knowing how to get all of these root 2 over 2, root 3 over 2 out, you can ask me at the very back. I will explain how to do it. Okay, but unfortunately, I do not have enough time to go through that now. Also, there is another way of actually memorizing this. I'll just write it very, very quickly. So we just take 0 over 4, 1 over 4, 2 over 4, 3 over 4, 4 over 4. So this is actually one of the ways to memorize sine. Then take note that cosine is just the reverse of it, and tangent is just sine over cosine. So that's why 0 over 1 is 0, what half over root 3 over 2 is 1 over root 3, so on and so forth. Okay, so technically you memorize one, you memorize the whole list. Okay, and this special angles is very important for questions that whenever they talk about exact values or those questions that require you to draw triangle, this is where you need them. Next, we're going to talk about quadrants. So quadrants is basically where you're going to be solving your trigo equations. Now remember the ASTC, or some people memorize it as CAST. Just take note that A means all ratios are positive, sine means all signs are positive, T means all tangents are positive, and C means all cosines are positive. So within the quadrants, you need to remember which ratios are positive. Okay, do not get confused with them. At the bottom down here, I talk about something about positive and negative rotation. Now, for the negative rotation one, if you have never seen it before, then forget it for now. Okay, positive rotation is basically just your very standard way of solving trigo equation. Negative rotation is just basically an additional layer that you need to check in case your question requires them. So some people will ask, when do you need to check? It's actually written there, when do you need to check? Whenever you see that your range is actually going even further than 0 to 360, then it is possible to go even more rotations or go even to the negative rotations. If you need examples of questions with this, refer to my monthly question series. There are questions there with this concept. Next, we're going to talk about trigograph. So this is the next section. So there are a total of 4 sections that we need to know for question types. The first type will be the ratios, which will have all those like special angle kind of question, or all those that require you to draw triangle. Okay, that's the first concept. The second concept is basically your trigonometric graphs. We need to know how to draw sine, cosine, and tangent. Your inverses and your cosecant, secant, and cotangent graphs, they are not necessary, just sine, cosine, and tangent. Some of the important features of a graph that you need to remember is that, for example, y equals to a sine bx plus c. The value of a is actually your amplitude, the value of b is your period, and the value of c is your vertical translation. Now, vertical translation, this word vertical translation is not really an O-level term, but I've introduced it here because I think it's pretty useful. Okay, vertical translation just means that your graph is shifting up or shifting down. Now, just remember that at the O levels, right, there is no shifting left and right. It's always up or down. So if you see yourself shifting right and left, something is very wrong. Okay, you should only be going up or down. If you want to shift left and right, you need to go further. Okay, then you will get it. Next, these are examples of the different types of graphs out here. So the notes are pretty detailed. So go and take some time to go and read them on your own. Okay, if you have any questions, feel free to just message me. The only thing that I want to stress will be about tangent. So for the tangent graphs, just be a little bit careful. Tangent graphs are a little bit different from sine and cosine. So for tangent graphs, right, you will have your maximum point and your minimum point. Your maximum point and minimum point actually do not exist for a tangent graph. So just be careful. Sometimes tangent graphs questions will ask you to figure out what is the amplitude of the curve. If you want to figure out what is the amplitude of the curve, you do need to calculate. Next, the period for a tangent graph is also different from your sine and cosines. The period is actually 180 or pi instead of 360 or 2 pi for the other two. The last one is the dotted lines. So you see those dotted lines down there, those are your asymptotes. Now just be careful, asymptotes must always be dotted lines. It cannot be solid lines. That would definitely be wrong. Okay, just like someone asked about that negative graphs. So just very recently, one of the years for N levels, they tested a negative tangent graph. It's the first time in the first 10 years. Okay, so just be careful. The way to draw negative tangent is just flip everything, treat the y-axis like a mirror. So for example, you will look like that. Okay, so if you can see my blue color graph on my screen, these blue color ones are the negative tangents. Okay, sorry. So this is how the graphs will actually look like. Okay, so a very good question. How does it have an amplitude if there is no max or min point? So in actual fact, the value of A for the tangent graph in front of A, right, is actually not amplitude anymore. It's actually something else. The definition for the A for tangent graphs is not very applicable. You don't really need to know. So just for now, just treat that number there. That's not very important, to be very honest. Okay. The tangent graph come out very often during exams with O's. It depends on your school. Next, we go into trigo identities. Now, I saw someone's question about tangent of negative something, right? Okay, those are under the identity section. So within this whole entire list here are all of the different trigo identities that you need to know. Of course, this is not everything. There's a lot more that I did not include. You can go and look for them on your own. Okay, the quotient identity, which is your tangent is sine over cosine. Your Pythagorean identities, this one are all already there. Addition formulas, double angle formulas, all these three are all provided during the exams. For addition, for the last one is your R formula. So R formula is just basically a bunch of questions on its own. They are very obvious when they are R formula questions. R formulas, you just need to memorize what the formulas are. But of course, most schools, I think, will teach you the proof for R formulas as well. In case you forget, you can always use the proof or just brute force the R formula using your addition formula to work out the values of R and alpha respectively. Okay. Is the formulas for complementary angles important? Answer is yes and no. No, you don't need to memorize. Yes, it may come up for exam. Can I go through half angle? Not now. Okay, because half angle not very common. Okay, so the one later. Last one, okay, which will be trigo equations. Okay, so for trigo equations, right, this particular section here, there's actually nothing much to say. I've actually provided everything that you need to know. I've given you an example question. Now, this example question here, the main purpose of this example question is to show you the different steps that you need to take whenever you are doing a trigo equation question. For trigo equations, number one, you need to remember that you need to find your basic angle first. You're not allowed to just straight away solve for x. You will get the question wrong. You must find your basic angle. Then you need to figure out what quadrants you're in, and then you apply your quadrant formula. Then you'll be safe for the equation section. There are some common mistakes that many people will make. One of them is very classic mistake, which is cancellation. You cannot just anyhow cancel functions like this. So for example, like 4 sine x cosine x equals to cosine x, you cannot just cancel the cosine x. You will get the question wrong. So just be careful. It's the same thing as your EMAF. For example, if you have 4x squared equals to x, you cannot just simply cancel the x. You will make mistakes. Last two things, substitution. So this is a very common kind of questions that always comes out for exam, which will always ask you to solve like this kind of funky equation, and you will see like a lot of fractions start to appear, squares start to appear. A very good tip that you can use, okay, is to do substitution. So for example, you substitute y equals to tangent x, and then the whole equations become a lot easier to solve as compared to just the base equation there. The very last thing that I want to say before we end off everything, extra rotation. So I mentioned just now, okay, it is possible to go an extra rotation. You need to watch the range of your graph. So for example, if you look at this particular question above, if you notice there's a 2 pi. Where did this 2 pi come from? It actually came from the extra rotation. And why is there an extra rotation? It's because, very simple. You look at the first two values that you have computed, which is 0 and pi. Do they fulfill every single thing in the range of the question? No. Your whole entire range of the question is between 0 to 2 pi. There is still that between pi to 2 pi that you're missing. So when you see questions that you have like one big chunk missing, suggestion is to go one more round to check again. Okay. So that is basically it. Okay, I know I went a little bit fast for the trigo section, but unfortunately I don't have a lot of time. Okay, so that's the best I can do. For those that have questions, right, can just wait a while. Okay, I will come back to your questions in a bit. Okay, so hold on first. Let me finish the other things first. Then for those that are want to leave, can just leave already. Okay, so a few more things that I want to say. Then I will host a Q&A session for like maybe 15 minutes to half an hour. Okay, that will not be recorded. Okay, so wait first. Okay, so this is basically everything that I've covered today. Now, I just want to do my giveaway, very quick one. Okay, so let's just settle that first. Okay, then I want to talk a little bit about the promotions that are going on. Okay, and then the services that I give. And then at the very end, I will do the Q&A. So let's settle the giveaway first. Okay, so number one, this giveaway, let's prioritize. I'm going to prioritize the Sec 3s. It's a little bit difficult for me to tell whether are you a Sec 3 or Sec 4, okay, unless you're not honest with me, okay, but if you're a Sec 3, do attempt the question, okay, it will help you, okay. I'm going to show you the concept, okay. So how will this question, oh, it's not stats actually, it's just basic algebra. Sorry, I made a mistake here, algebra. It's algebra. So basically what is going to happen is that on the next page, I'm actually going to show you a question. It's not a search question. It's just a very basic algebra question of medium difficulty. It may be a little bit difficult. Okay, I will not tell you where the question is from because you can Google the question. Okay, so I will not tell you. You must send your answer to me in the chat. Okay, so you cannot unmute and ask, no, I don't want. You just put your answer into the chat. If it's correct, I will ask you to send me your solution. So I need you to send me your working or explain to me how you get your answer. Because I know this question it looks very simple, but I need the working to prove that you can actually do the question. Okay. So I will definitely ask for solutions. So please go and try. I have 2 questions prepared. In case this first one is too difficult, there's a second one after that. Okay. So I wish everyone all the best. If let's say no one is able to get it, then no one gets the prize, unfortunately. Okay, so I'm going to show you the question right now. You have, maybe let's take about 5 minutes to do this. Okay, anyone that got the answer, you need to PM me, but I must show everyone, okay? Message to everyone. Then if I say that someone has gotten it, then I'll stop here. Okay, ready? 3, 2, 1. So I'll give you the question. So the question says this: suppose that x over a plus y over b plus z over c equals to the square root of 2, and a over x plus b over y plus c over z equals to 0. You need to find the exact value of x squared over e squared plus y squared over b squared plus z squared over c squared. I need working as well. Okay, so 5 minutes while I look at all the questions that everyone has sent, and I can slowly answer them later. Okay, someone got it. Very good. Wait. I don't know how to pronounce your name. Kiyo, is it? Yeah. Can you send me your answer? Can you send me your solution? Yeah, can you PM it to me on Telegram? If your working is wrong, I won't accept. I say first. I need the correct working as well. Yeah. I just provided my Telegram handle. Okay, I share first. The answer is 2. Okay, the answer is 2. But I need the working. I need every single thing written out. Because I know this looks very simple, but it's not. Yeah, I know the answer is 2. Everyone's sending me 2. Yes, the answer is 2, but I need working. So I will just go in order. So I see the first one is Q, right? Yeah, can you send me your solution? Then I see my own name. If he's wrong, he or she is wrong, then I'll take yours. And then I just go down the list. It's okay. Yeah, I need to fast because I cannot hold people. Okay, meanwhile, that is coming, right? Okay, solutions for this particular question, I will upload together with the solutions for every other thing. Okay, so all the other solutions in this revision package, I will put this question there as well. Okay, where is this question from? Since the answer is already out there, it's from Singapore Math Olympiad, 2001, one of the paper. No, it's wrong to just square. Yeah, so if anyone go and try to just like that square, like that square, like that square, no, it is wrong. Okay, obviously, that's why I asked for answer because I know everyone is going to do that. If you did that, that is confirmed wrong. Okay. I just pop my handle. Yeah, you just need to type, just search for my handle. Or if you cannot find me, you can go to the the OVERMUGGED channel, the one that posts today's the message. You just click on that and then message me. Yeah. Okay. So for the rest, right, I will not go through how to do. It's just a very simple computation question. So we'll just move on from there. I have the record of the chat. So if I see if this okay. Is that you? No, I think it's not you. Okay, yeah. So as long as yeah, I'm looking for the person to send me. Then after that, I will start. Okay, so I'm just going to carry on first. Okay. For the rest, yeah, I'm gonna carry on first. Okay. Yeah, sure, you can. Yeah, you can you PM it to me? Yeah, then I'll check. Okay, so I'm just going to move on first. Okay, I'm going to continue talking first, then we can cut off for today already. Okay, so this part here, I just want to share a very important quote, which is that every single concept is very important. Okay, but you can know every single concept, but you must practice lah, basically. This quote is actually from me. I said it last year, and it became like a meme to all my students. So I decided to put it here. So just remember that this concept here is very important. Okay, every single thing that in the AMAth syllabus is very important, but of course, practice is the most important thing. So you have to practice, okay, or else really this will GG on. Okay. I have some revision tips for everyone. Okay, so just be very careful. Whenever you are doing AMAth, okay, you do need to practice. This is the main arts of the subject. Okay, it's not like EMAth, where EMAth you can just wing it. You cannot. Okay, you do need to practice to get your stuff down, especially if you're moving on into Sec 4. Then you have, yeah, must be careful lah. Okay. Next one is to clarify your doubts whenever possible. Okay, so you need to clarify them as soon as possible. You can look for me, okay, when you need to clarify, or you can go and look for your own school teacher. They will get it. They will definitely help you. And the last thing is consistency is key. So for me personally, I do AMAth every day. Last time, I practice every day. I do pass your papers as much as I can to get as much practice as possible. For Kyo, if that is your answer, no, it is wrong. Yeah, the working is wrong. Next, I want to talk about this early bird promotion that is going on. Okay, so this is actually in front of my notes just now. I just want to talk a little bit about it. Now, this is actually what OVERMUGGED is providing. We are actually providing group tuitions next year for a lot of subjects, including IP and O levels. And the one I want to stress on is actually this early bird and trial package area here. So for the early bird, okay, this early bird promotion, this promotion is if today you decide that you like me, okay, and you want to work with me next year towards your O levels, okay, you can sign up for the early bird promotion and you will get copies of the curated notes, 3 subjects. So you can choose any subjects that you want. You will get priority selection in the timings. So we will give you priority I'll let you know when I'm free, then you will get to choose your class timing. And you will get this EOY revision kit. So what is this? Now, someone asked me previously if there's actually any other materials given. So the answer is yes. So at the very start of the session, I did share that I do have other chapters prepared. It's just not in this free version of the notes. I'm going to show you a sneak peek of what this is. It's here. So this is actually something that I've prepared as well. Okay, it's called the examination kit. Same thing for EMAth, same thing for A. So anyone that signs up for this, early bird promotion, you will actually get a copy of this version of the notes. It's the same thing. It's just that I've included more questions, and also all the chapters are more full, with more content, and also the topics that I didn't go through today, they are all here. So, for example, quadratic functions, equations, inequalities, indices and surds, simultaneous equations, linear law, okay, and also all the chapters will be here lah. Okay, so just take note of that. Okay, this is specifically for you. Okay, if you were to do that, okay, if you were to sign up for this early bird package. Okay. Next, I want to talk about this trial package. So this trial package is slightly different. So if let's say at the moment you're still a little bit unsure of whether you want to actually sign up for the trial class or whatsoever, okay, you can actually sign up with your friends and you can have a trial class with me and it's completely free. Okay, then I'll show you my teaching style and I'll show you what I can actually do to help you with your AMAth. You will get a free curated notes for 2 subjects, okay, and you also get to choose the time slots whenever necessary. Okay, take note that the dates and timings as well for these. So for the early bird, it's only until the end of the month. This promotion is going until the end of the month, and for the trial package is until the 31st of October. Okay, so just be careful. Okay, do consider carefully which one you are interested in. Okay, of course, if you're not, then yeah, it's fine. Next, okay, this is actually just what I want to share. Okay, what I want to share for all my students that I actually do for them. Okay, so yeah, for my students, right, what I actually do for them is I create lecture notes. So whatever you see right here, this revision package or this examination kit, is actually the truncated version of my own lecture notes lah. Okay, so I have created lecture notes for every single topic, and for EMAF, AMAF, and even for A levels, and everyone will get a copy lah if you come from my class. Okay. Next, okay, I do create homework as well. So for these homeworks, the question styles will be like those questions that you see in this revision package. The questions will be a little bit more difficult. Okay, it will be on the standards of like school prelims. I'll choose more difficult schools lah. Okay, and I've been keeping school papers for more than 14 years already. So since 2008, okay, I have a lot of school papers, and I'm here to just share my resources with them. Next, I hold class assessments. So I hold like little sessions with my students, okay, to help them go through like exams easier, and also just want to help them with their revision and everything. So this is something that I do. Class tests, I hold it once in a while. Within the OVERMUGGED channel, if you have seen it before, I've uploaded mock papers. That is things that I ask my students to come down, I'll book a venue, you'll sit exam condition, and you'll go through the paper. Okay. Full solutions. So I do provide full solutions, and for me, I'm a little bit different from most tutors out there. All these answers are actually handwritten by myself. I don't copy from school, or I don't screenshot off a school paper, or what. I don't photocopy assessment book. That's not my style. For me, all the solutions will be handwritten. The level of detail will be those of my monthly series, those that I upload every month previously. Last thing is resources that my students will get access of. So for example, all the school papers that I have, revision packages, I will go through the O-level papers as well. Okay, and I can guarantee success lah. Okay, so if you try with me, I believe your grades will improve if you do work hard as well. Okay, so upcoming sessions. Now I'm holding one more session. This one maybe not so applicable for O-level students, but if you're interested to see what is the A-level syllabus entailing, what can be even further, I'm holding a revision session next week, 8 p.m. to 10 p.m. This is for the A-level session. We're going through H2 math, and I'll be going through all the calculus topics. So if anyone is interested, you can come for it. Okay, it's pretty cool. Yeah, you can join us for that session. And last but not least, if you have any questions right now, okay, I'm going to start answering questions for the next maybe 15-20 minutes. So if anyone has any questions, feel free to just ask. Okay, and then also if anyone is interested in the trial lesson and also interested in the free package or the early bird, okay, you can just you can sign up using this QR code. Okay. If anyone doesn't have any other questions, then that's all I have. Yeah, that's all I have. Okay, feel free to leave. Bye-bye.